This is notes for compressible flow, and in this lesson we are going to governing equations for convergent divergent nozzle flow. So let's say we have a nozzle of this one with a small cross-section area here, and then it's become a little bit larger at the end here with a new or with the bigger cross-section area. So we point this area, this point is point number 1, and we point this one is point number 2. And we assume that the flow inside this nozzle means that the velocity is not changed with time, and it is isentropic flow. So isentropic flow means there are no extra energy release or no extra energies comes into the flow. So means that it is there are no losses in the flow. So at point number 1, we could say that the pressure is P1, temperature is T1, velocity is V1, and the density is ρ1. And then at point number 2 here, we assume that the pressure is P2, temperature is T2, the velocity is V2, and the density is ρ2. And then by the definition, the entropy remains constant in an isentropic flow. So because it is isentropic, we could say that the ratio of pressure over rho by the power of k must be constant. You could have this idea from your thermodynamic class. So, and then if we have 2 points, for example, please refer the above figure. So we could say that we could write P2 over P1, which is P is the pressure, is equal to ρ2 over ρ1 by the power of K. And we call this is the equation number 2. So, and then we have a general equation of states. We could say that P is equal to rho RT. So we could rearrange that equation. So we have P pressure, P1 over ρ1 T1 is equal to P2 over ρ2 T2. And then we could rearrange this equation becomes T2 over T1 equal ρ2 P2 over P1 times ρ1 over ρ2. So, and then we substitute with the isentropic ideas. So we could say that T2 over T1 is equal to ρ2 over ρ1 by the power of k minus 1, or it also can be written as P2 over P1 by the power of k minus 1 over k. So, and then we could say that the speed of sound, the equation of speed of sound is cert kRt, and then we could write that C2 over C1 is equal T2 over T1 by the power of 1 over 2, because the value of K and R is remain constant. So if you do this one, you could say that the value of K and R at point number 1 and at point number 2 is remain constant, because this is the specific ratio and this is the gas constant. So mean these two value will not change. So we could write as this one, and then we could substitute with the value that we get from the equation number 4 here. So we could say it is C2 over C1 also can be written as ρ2 over ρ1 by the power of k minus 1 over 2, or P2 over P1 by the power of k minus 1 over 2k. So let's say this equation is equation number 5. So, and then you could have an equation for steady flow adiabatic energy from your thermodynamic class. Okay, I simplify it here. So we could say that Cp T1 plus V1 square over 2 is equal to Cp T2 plus V2 square over 2. And then we rearrange this equation to T2 over T1, and then we could get this one. So, and then we could say that the value of V square over 2 CPT here, so it also can be written as V2 over 2k RT KR over CP, and then we could rewrite it as k minus 1 over 2 Mach number 2, Mach number square. So, and then we could rearrange above equation, so we could get that T2 over T1 is equal to 1 plus 1 over 2, k minus 1, M1, Mach number for point number 1 square, over 1 plus 1 over 2, k minus 1, Mach number at point number 2 square. And we call this as equation number 6. So from this is the final equation to find the temperature in point number 1 and point number 2. So, and then this equation applies in adiabatic flow. Friction effects are also negligible if the flow is isentropic. Equation 6 can be used in conjunction with the isentropic state relations given in equation 5 to obtain rho 2 over rho 1, and it becomes 1 plus 1 over 2 k minus 1 Mach number 1 square over 1 plus 1 over 2 k minus 1 Mach number 2 square, and with the power of 1 over k minus 1. And then to calculate the value of pressure 2 over pressure 1, we can use this equation, 1 over 1 over 2 k minus 1 Mach number 1 square over 1 plus 1 over 2 k minus 1 Mach number 2 square with the power of k over k minus 1. So these three equation is our basic equation to calculate any changes of temperature, density, and pressure in convergent and divergent nozzle. So please remember this equation. So if you could see, if the value of T2 over T1, the point number 2 is at the above side here, you will find that the Mach number 2 is at the lower side. And then the terms for this one, 1 plus 1 over 2 k minus 1, is almost the same for all the terms. And then you need to understand that to calculate the ratio of temperature here, so there are no extra power here, but for density and pressure, so you have the power of 1 over k minus 1 or k over k minus 1 here. Compressible flow, sometimes we need to predict what is the cross-section area at outlet at certain point in convergent and divergent section. So to do that, we will use the mass flow rate equation. So we have rho 1 V1 A1 equal rho 2 V2 A2, and then from this equation we could rearrange into this term. So we have A1 over A2, and then we have rho 2 over rho 1 V2 over V1. So the terms rho 2 over rho 1 is we could have equation from the previous derivation, so it's become easier here. And for velocity here, we change into Mach number terms. So we know that V2 is equal to Mach number 2 times c, which is the speed of sound, and then c can be written as third krt2 because this is the velocity at point number 2. Okay, we also could write the same thing for point number 1 here, and then because we are dealing with a same gas, so the value of k and r here is constant at point number 2 and point number 1. Please bear in mind that there are no K1 and R1, K2 and R2 because this is the constant for that specific gas, and whether it is compressed or not, the value of K and R is remain constant. So we could cancel the value of K and R here, and then we could write as this one. So we have A1 over A2, rho 2 over rho 1, M2 over M1, and T2 over T1. So the terms of rho 2 over rho 1 can be get from the previous derivation, and T2 over T1 also is given from the previous lesson. So if we solve this problem, we could have A1 over A2, and we could have this equation. So it is advantage for you to remember this equation, but if you don't remember this one, it is okay for you to do the derivation from the basic equation of this one. Please try this at home. And this is equation that you need to remember to answer the final exam. So the T2 over T1, rho 2 over rho 1, P2 over P1. This is the three common equation, and this equation is advantage for you to remember for the final exam and for this lesson.